look at number 4, but before we even get started, I wanted to note a couple things. So as you see, I've already highlighted a couple things for you. I did want you to notice that the x-axis and the y-axis both count by 2s. So this would be 2, 0, 4, 0, 6, 0, 8, 0, then 10. And then this next square would be 12. Also, where these key points are, they are not on whole numbers. So when I talk about them, I'm going to be using decimals. So it's not going to be an exact number this time around. If you had a question like this on a test or a quiz, there would be some leeway as far as what decimals would be acceptable. But I try my best on assessments to get them to be perfect numbers, to be whole numbers. So here are the 6 things we're looking for. So the first thing is the positive intervals. So the graph is positive in this section here and this section here. So again, like I said, I'm going to guesstimate. So it is start to be positive right there, and I'm going to say that that point is negative 10.5. And then it stops being positive right here, and I'm going to say that's negative 1.5. All I know is it's between 0 and 2, but it's a little closer to negative 2. The other positive interval would start here and continue to positive infinity this way. And I said that was 11.7 because it was way closer to 12 than 10, and it keeps going towards positive infinity. The negative interval, first one would be over here, and then in here. So down here is coming from the left at negative infinity, and then it stops there at negative 10.5. The other negative one would be here at negative 1.5 and continue all the way over here to 11.7. So now we're talking about relative max, relative min. This is a perfect graph to show you those things. So relative max is a peak. We have one of those right here. So I said that that point was negative 6.2, 20. Where did I get negative 6.2 from? 2, 4, 6. It's a little bit to the left. So I said it's a smidge 0.2, and then it's 20. Why is it relative? Because over here on the right, that arrow tells you that it keeps going. Relative min, okay, look at low. Here's a low point right here. Why is it relative? Because on the left-hand side, it keeps going even further down. So I said that that was 6.2, comma negative 30. How did I get 6.2? 2, 4, 6. It's a little bit more than 6, and it's at negative 30. Absolute max, absolute highest point does not exist because way up here, the graph keeps going up. Absolute min does not exist because the graph keeps going down. Number 5, how many possible x-intercepts would x to the 8th have? Okay, think about what we've talked about. We said that a linear graph was x to the first power, had one possible root. We said that a quadratic, which was x squared, had 2 possible roots. That a cubic was x cubed and had 3 possible roots, or x-intercepts. That a quartic was x to the 4th and it had 4 possible roots. This x to the 8th, if it was a function, would not have a specific name to it, but we would know that it would have 8 possible x-intercepts. Number 6. On the back of this handout, sketch the following. A concave down quadratic or parabola with a y-intercept of 4 and roots at negative 3, 4. Part B, a function with 4 roots has a negative interval from 1 to 5. And C would be a cubic function that has a relative max at x equals negative 3 and the relative min when x is 2. So there are many different options that you could have for those. On the back of this paper, sketch me graphs that have those specific details according to each part. You should have plenty of space. And then I'll go over them.